Good afternoon everybody and welcome to Rudy's Electronics Labs. I got a number of videos that I'm preparing right now, and I will be focusing on the CMU200 units of Roden and Schwartz that I've been showing in a couple of recent videos. So what I'm planning to do is make videos where we investigate this device for general purpose type of measurements. And I'm going to look into measuring power levels, and I'm going to do that also using this ICOM transceiver that can send up to 100 watts of power. I'm going to look into using the device as a spectrum analyzer. We're going to look into using this device as a signal generator. Yeah, that's another one. And we're also going to look at the specific audio module that this unit can support. So we're going to both look at regular type of audio signals, but we're also going to look at audio signals by RF devices. And for this I will be trying here this Sennheiser wireless receiver and this, oh I got the wrong one, this Sennheiser bell pack. This is a musician's bell pack. So that's already a fair amount of videos. I'm also probably going to make a little video about my experience trying to use the video output of such a device, which is VGA, but also a couple of other devices from about this era I've at home with VGA connections, and how you can actually record them directly into your computer using, for example, this VGA to HDMI interface, which actually caused me a lot of trouble to get it going, so I might make a little video about that. But before we go into those videos, I want to spend today's episode on a bit more fundament for the coming videos, because that is actually the question about what are the power levels that our CMU device actually can deal with, both as input and output. And actually that question is a little bit more complex than it might look at first instance. So today's video is going to dig into the power levels of the CMU unit. And to already give you a bit of a preview, where do the power levels really depend on? That is basically on which of the ports is used. You got 4 ports here and they differ in their characteristics. It depends on what options are installed, and I would like to say option between brackets, because one of these options I think it's actually more of a downgrade than an upgrade or so, but we'll get into in a second. It also depends on the specific measurement function that is selected, and I'll dig a little bit into what are the hardware reasons within the device that we basically got different characteristics and power level for different type of measurements. And finally, it also depends on whether you're using the device within the regular specified mode or into a overrange mode. So all of these factors play a role into what power levels we can actually use with the device. So let's go and dig into that a little bit. Now, on the device, as you know, there are 4 ports. I'll show them a little bit bigger here on the screen right now. We already see some indication about the maximum power level, some indicated in dBm, but some also in watts here. And what is really nice about this device, that there are actually the little LEDs that directly tell you which port is selected for input and output, which can be the same port as well. So 2 ports can serve as an input or an output, 1 port only as an output, 1 port only as an input. I think these lights are magnificent. I got one little issue, however, with the position of the light, the outlight over here. Maybe it's just me, but if I were to have my say, actually I would have that moved right up here. This, of course, I made this with my computer, this picture. This is not really how it looks like. But to me, it would make much more sense to have all the outputs on one line and all the inputs on the other line. But that, is, of course, is only a minor inconvenience. I really like the way that the outputs are shown. But now to the more fundamental point in terms of maximum power that the device can handle, because all the inputs are 50 ohms as you would expect, so there's a maximum voltage that will result in a maximum power to be dissipated in the device. Now, and in some devices, and if you're lucky, if you got the device, you will see here 50 watts written on the front. That device will be capable of dealing with 50 watts of input power. And in my very first video that I showed, I think, of the CMU, and where I also took one apart, we actually showed like the huge cooling facilities, the cooling block and fan inside for it to deal with that. So that's absolutely great. But you actually might also unpack your device and actually find out there's a little sticker attached to it which says 2 watts maximum. And actually I got 2 devices here that handle 50 watts, and I got another 2 devices that handle apparently only 2 watts according to this sticker. So what exactly makes a device a 2 watt device or a 50 watts device? Going a little bit deeper into that question now. Well, the first thing I was looking at is actually some websites that told us it depends on the version of the CMU that you have. And you might already have noticed that the most common versions are the 02 version and the 30 version of the device. Actually, there are some 4 different versions, I believe, of the CMU device, the 200, and there's also the CMU 300 device. I'm showing them right now on the screen. These are the versions that I'm aware of. These are the numbers that Roden and Schwartz assigned to them. And then I added some text, and that is text that literally comes from a Roden and Schwartz document. So version 2 is a device for what they say all mobile station and user equipment tests, including Bluetooth. Version 10 is their so-called high-end service tester. Version 30 is their non-signaling tester for board alignment and high-volume manufacturing. Then I got unit 52 specifically for Bluetooth test. And then we got the CMU 300, which is for base station tests. So many of the protocols are tested just the other way round. So these versions are actually specific configurations, I think, of the device in terms of options. But can you simply tell from the version of the CMU that you have how many power it can handle? Because that's actually what one of the websites that I started at looking at actually claimed. The answer is no. I got 2 devices that both are the 02 model number, and actually one of them handles 50 watts and the other handles 2 watts. So it's not as simple as that. We got an unusual moment of sunshine coming here into the house, so let's see if I can continue the recording, and the display will not be too bad. I'll just continue recording now. So we have to look a little bit further, and I think the best source to start from is the specifications of the data sheet of the device. So let's look into detail. Even there it's fairly complicated the way it's described. So we got at least 3 lines that should be indicative of what is going on. First of all, there is a so-called CMU U99, or also called B99 option, and that option basically makes the level range of the first connector, RF1, identical to the one of RF2. And it basically says that the input-output level range and the input-output level uncertainty, so it is valid both for inputs and outputs, are made identical for those 2. We'll see that in a moment actually how that works out for the device. Further on, it may also depend whether certain additional signaling units, or actually not signaling units, but signal generators are installed. If the so-called B95 generator is installed, we got a limitation on the RF1 port, and if we got the 96 unit installed, we got a limitation on the RF1 port. Now, I spent quite a while trying to figuring that all out, how that works out for the different versions of this device, the different configurations that I have myself. And actually I had to do quite a bit of testing as well, just to verify all of that, because I couldn't work out exactly all the combinations just looking at the data sheet alone. But eventually I got to a total overview, which I'm showing you right now, which I believe to be correct in sense of the maximum power levels. So what do we see on this sheet right now? All the way on the left you see the RF connector in question. Then in the next column we see whether we got this U99 or B99 option installed in the device. The column following is whether you have this additional signal generators, the B95, the B96 or none. And then we actually, the different colored parts of the table show you the input level, maximum input level, and that is all provided in green, and the maximum output level, and these are the cells in yellow here. I should note here that this data is provided for the 10 MHz to 2200 2200 megahertz range. If you go from 2200 to 2700, it's slightly different. Also, in some specific cases, the specified levels are for certain types of modulation. If that is the case, I selected the data for GMSK modulation and not for 8PSK. There's also some slight differences between what the data sheets sometimes say and what the device itself actually allows you to select. I'm not going into detail here right now. I want to stay at the bigger picture. Now, so let's investigate the levels that we see here a little bit more in detail. So first of all, there's of course the so-called 50 watt power handling. And what we can see from the table here is that 50 watt power handling is only possible if you got the device without the U99 option and without the two signal generator options, additional signal generator, a 95 and a 96. And only in that particular combination the device can handle up to 50 watts. Now, having to give that up, that 50 watts for one of the additional signal generators might be something that you want or not, depending on what you intend to do with the device. But the U99 option, or also called B99 option, to me it doesn't really make sense that you would like to have that. It is always a downgrade. In whatever scenario that I can think of, it's a less attractive device because the higher sensitivity that comes with it, you also already got it available on the RF2 port and especially also on the RF4 port, which is much more sensitive. So I don't get at all why you want that option. I think U99 in kind of every case is simply a downgrade. So I'm not really seeing why you see this in the brochure as one of the options for the device. Now, having said that, I want to now move a little bit more on how the type of power handling also depends on the measurement functions that you are using. And let us now focus here at the power meter, and in particular the wideband power meter features. And we see, for example, that on the RF1 port, without any of the two options I was talking about, the range there is from +6 to +47 dBm. So it only starts at +6. Actually, in reality, it's a little bit more sensitive than that, but maybe it measures with not within the specifications right then. So I don't want to make a big deal out of that. But this is so a pretty limited range. If we look at the other connectors, you see slightly different start and end levels of the range, but altogether the range is about 40-41 dB, as you see here in the table, except for the more sensitive RF4, where there's a 33 dB range, and that might be actually that the noise floor there is being hit. So all over, this range here is much more limited than if you would actually look at the range of the device when the wideband power meter is being used, where this range is so much higher. It's almost 90 dB of measurement range. So where does that remarkable difference come from? The frequency selective power meter, by the way, has quite similar specifications as you see here from the spectrum analyzer, where no minimum is provided. Now, to understand that particular difference, we have to dig a little bit into the hardware of our device. Now, let me show you how that works. Here we got the block diagram as you find it in the service manual. I had to put it on its side, but in a moment I think you will see why I have decided to do so. So we see in the left bottom we see the front end where the 4 inputs are, or actually there are 3 ports that can serve as an input. One was only an output, so they can be selected. And in a regular type of mode, and with regular I mean the use as a spectrum analyzer or the use as a frequency selective power meter, what happens is that one of these sources gets selected. It might have some attenuation or amplification. Then it goes all the way through the RX-TX board, where it goes on the RX side. There it gets demodulated, then it goes to the digital board. On the digital board there's an AD converter, then it's being processed, and basically from there measurements can be made. And then we got the really extensive measurements range that this device offers. Now, where is then the difference for the other scenario where we got a much more limited range? Okay, let me go to the next picture here, and what you see here is that some type of measurements, and then I'm referring to the broadband power measurements, actually take place in the RF front-end board itself. And we don't use the rest of the mechanisms like the TX-RX board, RX-TX board and the digital board and the digitalization things. It all happens on that front-end board. And let me zoom a little bit how that front-end board looks like. So this is the same picture. Again, this is taken from the service manual of the instrument. So we got a couple of different routing possibilities here. And what we basically see, there's a measurement diode over there. And that measurement diode is done to make broadband power measurements. And hence, it has a more limited range. What comes out of that measurement diode is also going to be digitized in one way or another, I assume. But that's another mechanism with other characteristics here. So trying to dig a little bit more into how that particular circuit then looks like of the pin diode. Here you see more zoomed into that particular peak detector side, and in each of the two peak detectors, and I'm only showing the schematic for one of them here, we got a diode with type number BAT6202W. And if you look that up, there are multiple of different manufacturers that make that diode, and its specifications basically are a low barrier Schottky diode for detectors up to gigahertz frequency ranges. And yeah, there we go, of course, that it will be fitting for a device, also suitable for pulse operation. So this is the type of diode that is specifically being sold for this type of purposes, power measuring on gigahertz type of bandwidth. And that's exactly what the device is doing. Why is it interesting to have it? I'll go a little bit more into that when I do the episode on using this as a power measurement device. But it basically would allow you to see right away, even in the screen on the device where you're selecting your input, how much the overall power is coming into the device and whether you're not overloading it, for example. So it's, I find it rather practical to have this information right away, regardless of the spectrum analyzer part and everything that comes up there. Okay, so far for the input handling possibilities. Well, maybe I should add here that the RF4 input is much more sensitive. There's a extra amplification stage at that one. It seems to deal a little bit with the noise floor as well, but we can go all the way to minus 80 dB measurements here. Now turning to the other side, which are the outputs of the device. And first of all, the most important output is the regular type of signal generator. But also here you will see that it really depends on the type of options you have installed in your device, what the possibilities are, particularly whether you got the U899 installed or not. But having that said, we always have free RF free connector here that I highlighted in red, and that one provides all the way to up to 13 dBm, which I think is pretty generous for the most type of things people will be using this for. I mean, obviously it's not a huge transmitter or so, but I think 30 dBm is not a weird type of performance characteristic for all types of stuff here. Now, perhaps the last thing I want to talk about in the video is the additional signal generators in the device. And they're called AUX-TX and the dual channel AUX-TX. So when we use this as a generic device, we can basically use this to create a second carrier, or apart from the first carrier that comes from the regular type of generator here. But as you see here in the, and you need one of the options then, I had already mentioned, the B95 or 96 option. The last one is the dual one. But as you will also see here, the signal levels coming out of it, depending a little bit on how it's configured and which port you're using, are very low. Sometimes we're talking about a maximum signal level of minus 60 or even minus 72 dB. So you might be wondering, what is going on here? Why did they care to put all this additional hardware in there to have an additional signal generator here, but only creating a signal as weak as minus 60 or minus 72 dB at its maximum settings? Now, to understand this, I think we have to go back exactly what this device was originally meant for. This was originally meant as a telecoms tester. And these second generators here, basically, I believe they were originally designed to be able to deal with particular telecommunications protocol, where you might have, for example, one carrier, a TDMA carrier, where all the traffic was going over, But if you would use all, for example, 8 of 8 time slots in GSM, you would actually need another carrier that would carry the other type of signal, like the BCCH type of signal, which is more for the housekeeping type of thing. So that would be the way that a regular GSM base station would be working. You would have normally at minimum 2 different channels installed there, 2 different transmitters, and one of them having this BCCH channel, and the other one could be full of traffic slots. And so you can mimic this basically in this way. And also in other standards, it might be important to have other type of carrier. There might be a pilot signal or whatever going on. So I think you really have to see the availability and the features of this in the light of what it was originally designed for. But we can use it for generic purposes, and I've used it for a couple of things, etc. But I hope this gives you some idea why we have this kind of unusual configuration of such a weak type of signal generator here. Now that also brings me to the end of this short video. I hope this gave you a bit of better fundamentals to understand the power levels at the device, so we can basically for the next videos we can fully concentrate on the type of applications that we can be doing with the CMU. Thanks for watching, and I hope to see you soon again if I have the chance to record the next episodes in this series. Goodbye.